All right, so unsurprisingly, I'll be talking about observables. I'm going to be doing a fairly intro one. Going to be more focusing on, the idea of observables, trying to show that they're not as scary as they might seem. Is anyone, and who here is at least familiar with observables? All right, we'll get there. Don't worry. So, just to give you some background, JavaScript, the way JavaScript evolves as a standard, they have this whole stage process. That's how new things get into the language. They actually have champions, is that the term? At early stages, you need to get a champion to say, like, I want this in the language, and then it moves on and on through the different stages. If you ever work with like Webpack stuff, you'll actually see like, oh, I gotta include stage 0 for blah, blah, blah sometimes. So that's kind of how the evolution works. Right now, observables are actually proposed for a later version. They probably won't make the next one, but they might make the one after that. They're also very popular. There's a big trend in JavaScript with all the new sexy frameworks that are all moving into either observables or something that's close enough to observables, even Redux, if anyone's familiar with that from React. It's not an observable pattern, but it works very similar to an observable pattern. So this, like I said earlier, this is basically trying to get you, like, what is the basic idea of observables? How do they work? How they model things? So, just kidding, I'm going to talk about arrays. No, but seriously, like, if you're familiar with arrays, you can get the basics of observables. They're actually way more similar than you would think. So, array, everyone knows what an array is. Very simple representation of information. That representation of information is in an order, right? Unlike a set or a hash map or any of these other concepts, right? So you have things in a particular order. One way to think about it is it's representation of ordered information in space. In this case, it's stored in memory. If you get it one time, you can get the exact same thing twice in a row. Doesn't matter when you get it. The same order is going to be there the whole time. All right. So, at least with JavaScript, you can actually throw whatever the hell you want into an array, right? They don't have to look the same. You've got some characters here, you got some numbers here. You got things like null, which you can throw in there. Any type of value can be thrown into an array, and they are just presented in the order they're presented in. Null or undefined are, not normal data types. They're different ways of expressing I either don't yet have information or this information is not defined in this particular case. There's a special case of using undefined when you're creating arrays. So there's a different kind of array or a way to think about an array. They're both JavaScript arrays, but they can be sparse, right? You can have some information in index 0 and then nothing in there, and then at index 200 you have something, and even under the hood. So when you create these kinds of arrays, under the hood they're actually not making room for those things until they need it. So they're actually going to make sure they're only making as much space as they need. But you can basically have an array that doesn't have information in places and basically has gaps in it, is a way to think about it. So, there's not everything, every single index all the time. All right? Okay. So, now by events, I'm not talking about the events in programming languages, the concept of events in that context. In this case, at least, what I'm talking about is like stuff happening in the world, right? Things like events are just stuff going on. So you can use events in a programming language to be notified when something happening in the programming world is happening, and then you'll have something like a callback mechanism or something like that. You'll have an event handler or event listener, depending on where you're working. They'll be called different things. Same idea though. So just like that in the real world, right? You're hearing me talk right now. You're watching me gesticulate because that's how I talk. You might be glancing at the slides. But there's stuff happening in the world. Some of those things are happening at the same time. Some of those things are happening one after the other. But there's different things occurring over time. Right? So now, if you imagine yourself to be just hanging out on the wall, you're not participating in creating the events, right? You could just be sitting there observing what's happening in the world, right? Got people moving, me talking. Like you can look at my watch right here. You can see the seconds moving. Eventually the minute hand will move, right? So you have like a bunch of things happening. So what you could be doing is, in some way you could say, I want to pay attention to some of these things, right? So if you want to pay attention to some of those, you are observing them. You know, you're not having an impact on that necessarily, because by observing them, what you're trying to do is say like, okay, I don't want to be involved in what's going on. I'm not a participant in what's going on. I just want to know what's going on so I can react maybe somewhere else accordingly, right? So like me talking right now, it's not making this second hand go particularly, well, I don't know physics well enough to know if that actually has an impact, but you get the idea, right? All right, so here's a way of representing different things happening at the same time and happening over time, right? Got my minute hand, it's going from 40 eventually to 41, going from whatever, pretty close to 40, eventually to 41. Every second hand is going. There's a relationship between those two, but you can think of them as two different things happening. And then you have different people doing different things in the room. Someone might be talking, someone might sneeze, cough, whatever, right? So those things, like an array in particular, like a sparse array, are happening in an order. This time the order that we happen to care about is temporal in nature, as opposed to what I described as spatial in nature. So an observation of those things can basically be thought of as watching things change in a particular order over time. Now, things might not be changing every single moment, right? But they are changing over time, right? So there's gaps, maybe, but you don't care about the gaps. You care about the next thing. And then maybe you wait a little while, and then you care about the next thing, right? Okay. So, as a result of that, you can see, we can think of these things as models of the state of the world or the state of some particular part of the world, like the state of my watch, or more narrowly, the state of my second hand, the minute hand, me talking, me coughing, me doing whatever. As those things are changing, you're watching changes of some state at a particular time, and then a next time, and then a next time, right? And then you can react accordingly, right? You can also say, okay, I've got the second hand position, and the way I figure out the second hand position is the second hand changes, and then you figure out what that means in relation to a circle, and that will tell you what time it is, right? You probably don't do the math quite like that in your head. All right. So, actually, my last presentation was on doing this kind of stuff with objects, but arrays are also useful because they're a really good model for kind of taking a set of information, in space in this case, and transforming them in some way, or filtering them in some way, or translating them into something else, like a string, maybe. Maybe you bring all the pieces together and you translate it into a string, right? So we use things like map, reduce, filter. Anyone familiar with at least some of those? Yeah, yep, okay, cool. So, just like an array, you can map each item in an array, right? You say, every time I see something, let's say we're working with numbers, I get a 1, my map function says add 1. So you have 1, 2, 3, you apply a map to it, you're gonna get 4, 5, 6. No, you're going to get 2, 3, 4. I can do math, simple addition, I promise. So, in a similar way, you can think of these things happening over time as being able to apply the same sorts of concepts. You don't care that it happens to be time instead of space. You just say, I got a value. I want to translate it every time I get a value. So if you have an observer and it sees 1, you have a map function on that. It says, okay, in this particular use case, I want to translate that into adding 1. So you have the exact same structural relationships. You can do the same sorts of things with observables as you can with arrays. So let's think about a particular case. So let's actually, so we've got a filter here. So what I'm going to do is first we can ignore these fancy things. So just comment that out. That's me being way too deep into functional and ES6. So you can ignore what these particular things.
What do you see?
Ah, swipe maybe?
Yeah, I don't think swiping.
Oh, I got to go out of full screen.
I get the stock repetition.
Yeah. All right. What about now?
If you zoom in, maybe.
Yep, gotcha. And let's make it a little bigger. All right. So my examples were speaking, sneezing, and coughing. So you can ignore all this. This is one way you could do it in using a particular observable framework. That's not really what matters. Basically what I've done is said, okay, I've got some things on the DOM. I'm going to grab those things. I'm going to listen to a particular event, click, and I'm going to say every time I click on speak, it should give me speak. Every time I click on sneeze, it should give me sneeze. Every time I click on cough. So this structure, when we look at human noises, and again, ignore the fact that it's saying merge, that isn't relevant, at least yet, right? I had to write the code to make this work. It's basically letting you say, okay, these are the things that are human noises, and I want to observe whenever any of them happen. So speak happens a bunch of times in a row, cool. Then sneeze happens, then speak happens. Theoretically, if I could click at 2 things at once, you might get 2. They won't show up at the same time because it's a single-threaded language, but you get the idea, right? Okay, any questions so far? Is this everyone tracking so far? No? All right. Or again, I'm kind of winging it. So, all right. So let's switch back over to here just so I can show you. Okay. So now we want to apply a concept like we would in an array, right? We want to filter out certain human noises. So let's say we're a nurse hanging out, and we were like, oh shit, someone's coughing, someone's sneezing. That's how all of my nurse friends work, at least. Okay, so what we're going to do is we're going to make another thing that's basically like an array, only it's something over time. So we're going to say, okay, I want, what was it called? Sick noises. And the $sign doesn't matter, that's just a standard out there. People argue over it. So what I'm going to do is just like I would do with an array. I've got human noise, and then I'm going to filter, and then I'm going to pass in a filter function. I'm going to use an arrow function just because I'm so used to typing it, I sometimes forget how to write ES5. So what do I want to do? I want to say, which ones? Well, I care about sneezes and coughs.
Christian?
Yeah.
Oh, did you mean to go back to that? I'm sorry.
Yeah. Yep. So I care about sneeze and cough, but not speak. So I'm going to be lazy and say, if it's not speak, then I care about it, right? So I'm saying noise, and then this is just a shorthand way of saying function has one argument, and then if that noise is not equal to speak, then I care about it. And then this subscribe, that's just how I say, I want to pay attention to this thing. Yes?
Double equal.
It doesn't matter, but yeah.
Oh, it doesn't. Oh, that's right. I'm so used to it.
It's cool. I yell at them for not doing that, so that's my basic. No, it's cool. It's cool. That's funny. Okay, so now to demonstrate, I will do sick noises dot subscribed, and log is just a short way of, because I'm lazy writing console.log. So we'll notice sneeze. Oh, let's turn off the other one because that's going to confuse us probably. All right, so I do sneeze, I see sneeze, I do cough, and now moment of truth, nothing, right? Clicking on speak if you can't tell, right? And it's filtered out, right? I've created, just like I would with a standard array, just a filter out the things that I don't care about, so I can narrow down and pay attention to just the things that I do care about. Right? Pretty simple. That's why I said ignore this. It looks scary, but it's actually not. All right. So let's see if I can figure this guy out again. Okay. Yay! All right. Cool. All right. So mapping. Similarly, we've got seconds passing. So I don't have this yet, so we'll live code it. But let's go ahead and try and do at least something like this. 2-angle. Let's figure this out. So there's a little.
Show what? Show what?
Oh, thank you. I would have forgotten that. Okay, so just comment that out. All right, so what do we want? We want a second passing. So let's start there. So call it seconds, and then we'll do rx observable. And this is just another simple thing. It's very similar to when you do set interval in JavaScript. This is just a shorthand way of making an observable based on that. So I'm going to say, just like you would in a normal set observable, it's based on milliseconds. So I'll do interval of 1,000 to be 1 second each. So now if I add this just so it stops. Hang on. Okay, so now if I do like before, subscribe, log, should be able to just, it auto ran, cool. Okay, so 0 through 4, that's the take 5, but every second you saw a new observation, and we can rerun that just to demonstrate, right? Okay. So now, instead of writing a 2-angle, which, well, let's see. No, I don't want to do the radian map. It's very simple. I just am doing this on the fly.
6 degrees
6 degrees.
per second.
There we go. All right, I will do that then. Okay, so let's make a little function. Const 2 second angle is equal to second. And then that will, again, this is just ES6. It's like I wrote function. I'll try and write an ES5 function. Yay.
Yuck.
All right, fine. Deal. I don't want to write it either. Okay, so we get a second, or seconds, I guess, and then we want to yield the number of seconds times 6, right?
Sure.
Yeah. All right. So now we need to do one more thing with that before we apply it, which is we also need to make sure that every 60 seconds, it goes back to 0. There's a really easy way to do that. Const 2 second interval, we'll call it that. I don't know what to call it. So now we're going to take seconds, and then we're going to do, well, that'll just be seconds modulo 60, I do believe. So let's verify that. So now we're going to do, we'll keep our, well, we need it to go farther, so we'll do take 120 just in case. And then we'll go ahead and say, okay, well, first we need it to reset every 60 seconds. Let's speed it up just to see it. And then this is just going to be mapping, right? In fact, let's just demonstrate that first. 2 second interval. So we should see it go to 60 eventually, and then reset. Good. Okay. That was also for me to make sure everything is working. Okay, and then we'll go ahead and do our second map, which is to the angle. Second angle. And then we got some angles. We should see 360 and then go up. Right, 354 to 0, right, yes. Yeah. That makes a lot of sense. Yep. Better not see 360 is what I should have said. Good. Okay, cool. So now we have basically something that's saying, okay, if I'm observing every second, we're going to try and reset it for every minute, and then we're going to translate it into what this angle should be on my watch, right? And there we have it. So if I got rid of take 20, that would go on until my computer crashes. Okay, cool. I have no idea how much time I'm supposed to have. How am I doing?
50.
Cool.
Minutes.
All right.
Yeah, half hour. No, you're fine.
So I unintentionally, since I didn't write this presentation, just demonstrated chaining, right? I had map to the reset and then map to the angle. We could do the exact same 2-second interval in order to, or something very similar, to then create a minutes observable. So if we wanted to throw in a minutes observable, what we could do is say, since this is, damn it. Thank you. I will probably need that every time that happens. If you're okay with it, so am I. Okay, so right now I cobbled all this together, but let's make this just seconds, and we'll comment this out. Let's comment that out instead of, god damn it. There we go, hit the right key. And then we can go ahead and do minutes, $ is equal to seconds. And then that would be, oh, that's 2-second interval. We don't want that. Hang on. We just want this to be we'll do 1,000 again. Now we'll do 100 because we want to see every second. Okay, so we have seconds, which is, we're going to pretend every 100 milliseconds. And then minutes is just filter, yeah, filter, and then it would be x mod 60 again, right? Not x mod 60. It would be not x mod 60. Sorry, this is shorthand stuff. If this is confusing, 0 and false are similar enough in JavaScript that you can treat zeros as false. This is a simple modulo math that just, it's like division, but it gives you the remainder. So I'm saying I'm going to divide x by 60, and if there's no remainder, it's going to equal 0. So every 60 seconds, it's going to equal 0. So I want to keep the ones that do equal 0, so I need to say not that. Cool. Everyone good? All right. Okay. So let's do $subscribe now, and again log it. And then eventually, we should see a 1. Or 6. Ah, I forgot to map it. Sorry, guys. It is not 60 minutes later. Dot map. And then that. Oh, actually, I can use this one, which is just shorthand. Nope, I need to use map. Or I can use scan.
Scan.
Just use map.
Sorry.
If you want to keep going, you gotta use
Just
scan.
use map and people.
What's that?
Just use map. Go for it.
Yeah, you got it.
And we don't have to learn so many concepts.
So then the map, the reason x module or divided by 60, and then I need to actually, that should just work. There we go. All right, cool. Okay. Everyone good so far? Learning stuff? Yeah? All right. Cool. Hopefully not learning math and learning observables instead. Okay, so I could have written similarly a minute hand to angle, same idea as we did with second hand, right? And you saw that you can just like with arrays, you can do a map, then another map, then a filter. You can just chain them all together, and the end result will be whatever it is you care about. This is very common in functional programming, and in this case, this would be functional reactive programming. All right. So, similarly, if we see here, I'm trying to remember what the hell I was trying to do here. Let's see. Last time, This is just another way of doing the same thing. Yeah. So probably a scan, not a reduce in this case. I'm going to hit escape, guys. So if you look, what's that? I didn't yet. No. I was.
I'm gonna hit escape, guys.
He was warning us that we're about
Didn't
to.
do it.
This is a psych out. You fell for it.
Yeah.
No, so in this case, this is basically showing how you would do it with an array, right? You have a bunch of data, and then it gets to 0 again. This is showing add a second to try and represent what time it currently is based on last time. So instead of observing 0, 1, 2, I don't know my current time is 0.9. Oh, I see what he's trying to do. All right, we're just gonna move on from that one. Probably a perfectly good example that I didn't have context to figure out. All right, so now we get into a really fancy one. This is basically, and if I have time, I could cobble this together. So this is basically trying to model together an entire clock based on time. So this is kind of showing a bunch of things together, right? So if you have, you can think of merge as saying, all right, I'm gonna take all of these things and pay attention to all of them. That's what I was doing. So if we switch back to escape first, here, and we look at this commented out stuff. So what I ended up doing was taking a bunch of different things that I could observe. And in fact, let's go ahead and comment that guy out and grab these guys. So now if we look at this code, you can see, okay, this is translating events into observables, so I can just use them in the way that I can compose other observables. And all they're doing is saying, okay, I want to pay attention to this for speak. Well,
You're listening to sick noises.
Yeah, you're
Any of
oh,
those-
so you're not going to see speak,
You're not
but
gonna
thank you. So, you know, if I click on sneeze, all this is doing is saying, okay, in this one, I care about sneezes. This one, I care about coughs. And then human noises is just saying, okay, in this one, I care about all of those. So I want to know when any of those happen. So that's why our console log is going to give us both of these. And in fact, in this case, I'm saying, okay, I might have some use cases where I care about any human noise happening. But in this narrow case, I only care about sick noises. So I'm going to get the wide net and then filter it out, right? So that's why we're not seeing speak. So that's what merge is doing. It's basically saying, okay, and if you think about arrays, you don't generally relate to arrays this way unless you're doing fancy Lodash stuff. But you can think of like 3 different arrays providing information over time, and you're saying, okay, I want to kind of bring them all together into one super array. And anytime any of them have a value, I want to make a new array that populates that particular index with that value. And then you can follow that up by filtering out the ones that are irrelevant. All right. So now let's put it back into the context of some of the other things that are used for similar things, right? The 2 most commonly used ones in JavaScript are going to be events or event streams, if you're on the node side, or promises. So while there are similarities between them, I think it's useful to see why they're not the same rather than why they are the same. That's why I actually think array is a really good way to understand it, because it's much more like an array that happens over time than it is like an event or a promise. So one of the big things with events or event streams, you don't actually know when they're done, right? There is no, unless you're listening to some other event that you were told, hey, this means they're done. And then you have this other one which says, this is the next event. And then you stand in front of the presentation and you observe that, which is a bad joke. They also don't have any built-in concept of an error has occurred, right? Arrays don't also, but that's one of the ways they're not like arrays. But you basically have no way of distinguishing between different things that are happening to the thing you're trying to pay attention to, unless you have this ad hoc, like, oh, I happen to know this will dispatch this event under this condition, and I happen to know that this one will dispatch at this condition, and so you have to try and like pull them together. And similarly with the compositional model that I was just showing you, where I can like chain things together or translate between things, there isn't a built-in way with any standard implementation of events to do that. You kind of just have to do that on your own, using the callbacks, wrapping them in functions, getting them to be more similar to observables in order to just do the thing you're trying to do that observables kind of provide for you out of the box. And then another important thing is, because I'm not just here to bash events, for example, the most common use case and where they're especially powerful is for understanding parent-child relationships, right? The most common places you see events heavily used are when you need, like, this guy up here needs to know when that guy down there is doing a thing. So you have to have this relationship of bubbling and capturing to be able to pay attention to those pieces, right? Promises. Anyone in here familiar with promises? Cool. All right, so promises are in the spec in ES6 right now. They've already been added. In fact, they have added other things that use promises. And they're very good for certain use cases. They also have been tried to be fit into use cases that are better suited by observables. And it gets really ugly if you've ever heard of callback hell in the either promise chains or in callback structures with events. It becomes really hard to structure. Never.
No, callbacks. If you do your promise layering right, you don't have the callback hell. That's the problem. You know what I mean? Like if you do it right,
Sure.
You don't get it. That's why I said no, not quite.
Yeah, no. Again, I'm not trying to bash promises. Promises are really good for certain things. There are a few things that they actually are insistent on. They were the two first bullet points here are more like, okay, first they were modeled around this idea of like try, catch, finally, which you see in these blocks of making sure things are happening the way you want them to happen. You have the exception case when they don't happen the way you want them to happen, and then you have the thing that happens at the end regardless of whatever happened, right? So there's kind of a parity between next, error, and complete that you get with observables, but it's not trying to be the same sort of thing, right? It's trying to handle a structure that's similar to this, only making it an asynchronous structure, making it something that you can relate to whenever you have that first thing happens to happen, right? They're also
We do have, async and await kind of solve a lot
Coming.
of that now.
that's also I think ES7. I think it made the spec for ES7.
Yeah, it's in Node 7.8, like I started
Yeah.
using it immediately.
Yeah.
But the translation back to ES5 is ridiculous.
I haven't looked at
It's
that yet.
like 4 lines of code becomes like 400 lines of code. It's just like
Yeah.
you can do it in a little online Babel REPL.
Yep.
It's awful. So I would
Yeah.
recommend doing it.
I would
for
be
any
interested in that.
client-side
Yeah. So this is a very dumb case, and it can do far more structural relationships. A lot of the open source libraries out there for promises have a bunch of additional operators to do things like things happening in parallel and bring them back together, and have this one operator for if everything happens successfully. Have this other one where it allows for failures in some of them. So you can do a lot of powerful compositions, but it's trying to model a different sort of structural relationship. Yeah.
I'm not that familiar with promises, but isn't it, I've mostly heard of it used in single shot kinds of things as opposed to observables, where observables, I think you're going to get just essentially an endless stream.
Yeah, and a lot of the
promises are once one thing happens. And
Yeah, that's the most common use case. I actually don't remember if the Q promises specification has in it next, but a lot of libraries actually do have a next-like thing, so you can observe.
keep observing.
You can keep observing.
Keep promising, as it were.
Yeah. It's like a continuing promise. I promise. But But it's called promises for a reason, because the core use case is to say, like, I promise to do this, and once that promise is fulfilled, then I will do this other thing, right? All right, and then this is one of the things that I didn't know until much later, and I had to reconfirm with Jared earlier today. Promises, by definition, have to be asynchronous. So if you have something that you want to ignore whether or not it's asynchronous or synchronous, promises, if they're implementing to the specification, will still say either they'll do a set timeout 0, or they'll do a request animation frame. They'll say, no, this is not going to happen right now. It's going to happen maybe really soon after right now, but not right now. Yeah. And then there are similar things that have other relationships. Like another way to think about the relationship between observer and observable can be connected up with, they're kind of like the inverse, if you've heard the language of duals. It's okay if you haven't. They're kind of like the inverse of an iterator-generator relationship, which is in ES6, right? So a generator or an iterable, if you've worked in languages that have the concept of iterable, you basically will have some way of saying, I want to get an iterator over this iterable. And then the iterator says, okay, I'm going to call next every time I want something next, right? So, yeah. So it's basically pulling the information and saying, okay, I'm in charge of when I get the next thing, right? I will tell you when I want the next thing. Observable observer, on the other hand, is the inverse relationship. You have an observable, which says, I will tell you when the next thing is coming, and you will react to that. But you can actually do some really powerful structures and relationships and architectures by taking advantage of both of those at the places where they actually make sense. So sometimes you do want a push-based model, sometimes you want a pull-based model, and you can actually create seams that connect those two in smart ways. All right. So I guess this was the end of my slides. I wrote these last ones, so I should have actually anticipated. Okay, so if this seems like something that you think could be useful, at least for some use cases, I'm definitely really deep on board with this stuff at this point, as are most of the people working on the projects that I'm running. But there's a lot of powerful libraries and implementations. So the three most popular JavaScript ones are RxJS is probably by far the most popular at this point. Bunch of big companies are using it at this point. It's made its way into Angular. It's made its way, I think, Dojo 2 used its own implementation of Observable, but they were using RxJS. And they also have
recently switched to
yeah.
their own implementation.
Yep. And they actually have a internally supported plugin model to use Rx if you do want to use all of the operators and stuff from Rx. Cycle.js is another framework out there that uses Rx. There are things that are, if you're familiar with the way that the model side of React is not part of React, there are several libraries out there now that are doing an RxJS implementation of something that's very similar to Redux. So they're very heavily used, and like I said, we've got the proposal here, which, as I was saying, it's a very simple, the core of what an observable is, an observer, is very dumb. And apparently that is not a real link that I can click on. You're lying to me. Not you guys. So if you look at all of what's in the spec for observable, you've got a thing that defines observable. It's got to have something to subscribe. There's a couple of ways you can do the subscribe.
Not readable.
Oh, let's do that. How's that?
Readable.
Good? Cool. All right. So observable, it's basically, okay, you need to be able to subscribe to it. What do you subscribe with? An observer, or just a function, right? That's what this is saying. Then these are just some convenient ways, or factories is a way to think about them, of creating different kinds of observables. Like this is literally allows you to convert an array into an observable, right? And then you have another thing called a subscription, which allows you to unsubscribe. That's the thing you get from the subscription. That tells you I'm done paying attention. We can ignore these two guys. They're not that complicated either. And then you have an observer. What's an observer? It's something that has a next function so that the observable can say, here's your next, here's your next, here's your next. It has an error function that allows you to say, oh, shit went wrong. Here you go. And then it tells you when it's done. That's all of the specification. And then this is a more specific version of subscription. It adds one little function or getter that tells you, is the connection closed to the observable? That's the entire spec. So you can write this up in a very small number of lines of code. So the core idea of observable, very simple but very powerful. Cool. Any wait for it.
Observing.
So I highly recommend both of these sites, by the way. We made all these guys go through. Egghead.io has a lot of really great.
Except for Joe's courses.
Yeah, not great. And then LearnRx is one written by someone who has contributed to RxJS 5. It's Jafar Hussain, really smart guy over at Netflix. He was spearheading very early. He has a great recorded presentation you can find all over the internet, where he says, "What's the difference?" Which blew my mind when I first heard it. What's the difference between an event and an array? So that was another entry point for this. This is basically some walkthrough training that you can do of the LearnRx. It goes from arrays into observables. It's really a good way to get your head into it. And then questions?
Yeah, I got a question.
Yeah.
Weren't there two competing libraries with the same name with RxJS? Like there were two versions of this thing out there.
They were
the versions of RxJS.
Yeah,
It's
right.
the language, but it's all the same thing. The reactive
Yeah,
extension
they're this-
started off as
Yeah,
Microsoft.
that's the one. Yeah.
But it's the same thing.
Yeah. Do you want me to explain the confusion? They were changing infrastructurally kind of like ownership, and it was such a massive change with the 4 to 5 that they abandoned ship on the so you have both repos just hanging out.
Yeah.
So I could understand why you would think they're competing or like produced by different people. Nope, they're both open source. They used to be owned by Microsoft. They're not anymore. Went completely open community now. But yeah, it's
Okay.
yeah.
Yeah, it's not just JS. I mean, it's everything. It's
Yeah.
Rx for everything.
Uh-huh.
Yep.
Yeah, any languages.
Yeah.
Cool. Other questions?
Thank you, Christian.
All right.
Thank you.